I'm going to show you how to calculate critical value, margin of error, and then bounds for confidence interval for the population mean. In this example, I have a population of 1,500 observations from a normally distributed variable, and this has a mean of 10 and a standard deviation of about 5 here. In this problem, I've already done it in Stapplet to find these upper and lower bound, so we'll be able to check the answer there. And what I'm going to use is confidence here. This C cell is an input. So I'm going to start with my 95% confidence level. And then to find the critical value, this is a little bit tricky in Google Sheets or Excel. You have to use a t-inverse function, t.inv. And then you need a cumulative probability. And that is actually going to be C plus, okay, so C is actually in column D5. I need to use that. Plus, and then it's the complement of C divided by 2. And that's going to be the left tail. So we're doing the left tail plus the middle area. Each tail is the complement of C divided by 2. And you could use algebra to kind of write this differently if you want. But that is how I'm going to do it, just kind of a little bit more intuitively. We take the left tail plus the middle percent to get a total percent to the left of that upper end of it. And then the degrees of freedom here is n minus 1. So I'm just building up a formula. You could, piece some of this out separately and reference it, but that'll be a way to get that critical value t. I do not want to autofill there. To get e, there's two ways I could do it, and so I'm going to put these side by side. The first way to do it is confidence.t. Alpha is 1 minus the confidence level. Standard deviation is S. You could also use the standard deviation command in there, but since I've already got it there, I'm just going to reference it. And then the size is 25. So those are the inputs for the E function. Get a margin of error of 1.97 for this sample. And then lastly, the lower bound is equal to the point estimate minus the margin of error, so D2 minus D7 on that one. And the upper bound is equal to the point estimate plus the margin of error there. So we end up with 9.71, 13.66. That is the same thing we've got here. The fortunate thing about this method is we can make it, we can add precision to it, or we can reduce precision depending on what we want for those values. We also have more control over finding critical values and finding the margin of error separately. Now, like I said, there is another way to find margin of error. That's using the formula. The formula for that is the critical value times the sample standard deviation divided by the square root of n. And so that s divided by square root n, that is the standard error for this distribution, and it's basically the size of a standard deviation, and then the critical value represents the number of standard deviations, so it's how many standard deviations, how wide is it, and then multiply together to get that margin of error. And so same thing, two different formulas to do it, but that is how we would do all of these calculations for estimating the population mean.